Okay, so first of all, as usual, a little bit of practical information about the schedule. I mean, nothing new. I didn't change anything except adding, the links to the material and the solutions for last labs and so on. So this week we had labs on Monday and Tuesday. Next week it will be normal. Okay, so lecture on Monday and on Thursday as well. Later today or tomorrow I will update the schedule, and I will also put something for the week after, so you have a little bit of view about next week's as well. Okay, if there are no questions, I would go on with the what we decided to have in the schedule. That is talking a little bit about the browser security. Okay, so now we have a very powerful tool that you experimented on Tuesday in the lab, so we can execute code in the browser. Okay, this is very powerful. You can create elements, you can manipulate elements in the page, which can change the appearance and so on. But as you might surmise, I mean, it can be very dangerous if it is done in an uncontrolled way. Okay, so there are a lot of restrictions and attentions that we need to put in developing code for the web to be executed in the web browser, because the code can perform unexpected manipulations that lead to problems and security issues in general. Okay. So basically today we will talk about these cross-site scripting techniques and especially how to avoid them. Okay. Actually, there are quite there are a set of quite simple rules that can be followed to avoid major problems, let's say. Okay. So the browser environment. Basically, you experimented in the lab. What happens is you go to a website, or in your case in the lab you loaded a file, an HTML file, and the browser gets the HTML content. The content is interpreted, and it's parsed. It constructs the DOM tree, and also it has the possibility to refer to other resources, like you saw CSS. We saw JavaScript code, images as well, but images are not that a big problem, I mean, in general. And the point is that this JavaScript code, it will be executed, right? So it's code that will perform actions. And the browser works in this way until it solved all the references that it found into the page. Okay, so it loads all external resources and all the scripts are executed. Okay, and we already talked about the fact that when we load the code, we need to be very, very careful, because the code can come from untrusted sources, right? So either it comes from our web server, and so it shouldn't be a problem because it's our web server and we decide what to put on our web server, or it can come from external resources, external systems like CDNs and so on. And that's why we had that integrity check that we wanted to put when loading content from a place where we don't control the content. Okay. Okay. What's the problem with this external content? The problem is that it can perform unwanted actions like stealing information, sending information to some places where we don't want the information to be sent, and so on. Okay. This goes under the name, very, very general name of cross-site scripting, often abbreviated as XSS, okay, for cross. Well, basically, this cross-site scripting means that some malicious kind of code or other in JavaScript or in other languages, even in HTML, is inserted or is put in some ways into the normal flow of execution, of processing of a non-malicious web application, okay, a website in general, okay. So there are different ways in which this situation can happen, and the point is that the browser doesn't know that this piece of code, if it's JavaScript or HTML and so on, shouldn't be executed because it thinks it comes from a trusted source. Okay, so it doesn't realize the fact that it was inserted or put or given by some untrusted source. It's not so evident. Of course, if we are loading the information from an external place, like we did with the CNN, that's very evident. And so indeed, that's not a problem if we have this integrity check and so on. But in general, if you are able to tamper with the normal execution of the application, inserting something which is not expected and for which the code doesn't protect the application, that will be a problem. Okay? And the problem is because the code can basically access all the information that is available in the browser, okay, as your JavaScript code does. So it can access sensitive information, often things like cookies, secrets, tokens, and so on, that are basically the way in which you tell other web servers who you are, what are the permissions for your actions, and so on. So it's really dangerous if this kind of information is stolen. And it can even modify, rewrite the page content. So basically changing what is shown and tricking the user in some unwanted behavior. Okay, like showing a form like the web page of your bank account and tricking you inserting password or whatever. Okay, so when you have access to the DOM, basically you can completely change the appearance of what is shown inside the browser window. Then that is the problem. We will see, different types of cross-site scripting attacks, and we try to classify them in some categories, but this is not really the important thing. We are not trying to, we're just seeing some security aspects for web application, but just for the purpose of avoiding the most common mistakes. Okay, we are not trying to give, focusing only on security. Okay, but there are really basic mistakes that you really need to understand in order to avoid them. Okay, and we now see some common mistakes that can be made while developing web application and how this can be avoided. Okay, so the first situation we need to avoid is when some user is tricked into basically clicking on a link that performs some unwanted behavior. And typically these links go to a web server, and the server, which is not protected against this behavior, so has a problem in the way it was programmed, reflects back the response, okay? And so basically tricks the user into doing something unwanted, because the browser executes code that came from an external place, the attacker. Okay, so the attacker creates this this URL that in some ways bring information to the server, and the server does a mistake. That means takes this information and send the information back to the user in some form, for instance, as a part of a page, and and so the browser will execute this part and will trick the user in performing something which is not expected. Okay, or maybe simply if it's code, it can steal sensitive information and so on. Okay, just to clarify the ideas, let's see an example. Okay, I mean there's a URL that in some ways is used by some people that click like on a link that has been sent by email. Okay, that's a typical situation where people click without thinking too much, and the server, for some reasons, I mean, because it was programmed thinking that only good input was passed to the server itself, just takes the parameters, typically the parameter part of the URL, and use it to construct what is sent back to the browser. Okay, and so the browser, in this case, executes some code because I decided to say, okay, I pass a request for a page that does not exist, and the server replies telling me that that page with that name that has been passed does not exist. But unfortunately, that name contains some active code that will be executed by the browser. Now here the code is just pop up a window just for for testing. That is a very compact code, and you can see if it gets executed or not. But I mean, the principle is that we are in this situation in which an attacker has created this malicious URL, and the user clicked on the URL, and so opened the browser and sent a request to the server, and the server reflected the information back to the browser, which executed the content. I mean, this example was done with JavaScript code because it's really easy to understand in this way. Okay. So that's a possibility, and this cross-site scripting attack is not persistent. Okay, so every time you want to execute this attack, you need to have somebody clicking on the link. Okay, you need to make a new request with the malicious code to the web server. Okay. We can also think of a variant of this attack, which is persistent. So at a certain point, there is some malicious actor, this attacker, that interacts with our web application. I mean, the web application in general. And this attacker is able to store some information on the server that will be later used in another at another time instant by the user. Because, for instance, it is stored in a database, like a blog post or some other information that is meant to be shown when the user performs some legitimate request, like listing all the contents, the post, and the text, the details and stuff of some information that is present on the web server. Okay. And again, I mean, the principle is exactly as before. The only difference is that if the attacker is able to store the code permanently on the web server, there is no need to have the user click on some links and so send the request every time. Just the user normally interacts with the website, very normal way, I mean a usual way. It's simply when it encounters the content that has been inserted by the attacker, it will be subject to the attack. Okay? So again, another example. There's a forum where I can put a I can insert the posts, so articles and stuff, and they allow me to insert HTML code because it's a technical blog where you tell people how to use HTML and so on. And so basically you cannot simply say, well, I forbid writing HTML code. I mean, the purpose of the blog is explaining HTML. So HTML is something that must be allowed in a way so that people read that information. Okay, but unfortunately, if somebody insert code like this, okay, HTML that execute JavaScript code like this, and then a user, a normal user, I mean, that has nothing to do with the attacker, visits the website and scrolls through the posts and look at the posts, and it encounters the post that has the malicious code. The malicious code will be interpreted by the browser to show the content of the post, but also it will execute indeed the malicious code. Like, again, this is exactly the same as before. I mean, just to show an example, a script with some JavaScript code that performs some action. Here, the information is already stored on the web server. So basically, every user that will encounter this post will will be subject to the attack. Okay, there is a question, right?
How the attackers can inject code in the website?
Well, actually, because this is just normal content that you take from like a form, an input, text area, and whatever. You, instead of writing text, you write HTML code, and the HTML code is supposed to be executed by the client. Of course, it's not a good way of programming a website, okay? But it's a risk. I mean, that you can have. I mean, like for instance, you go to some forums or whatever, and sometimes they allow you to insert some HTML tags, right? Because you want to have some bold text, you want to have some italic text, you want to have code segments, so some text that change the font type and so on. Okay, if they are not very careful and they don't exclude dangerous text, but I mean, this is just an example. I mean, you can achieve the same result with less dangerous text. This is really evident because it's script, and of course script probably should be restricted in some ways. But I mean, there are other ways. We will see an example today on how to achieve this behavior also with kind of innocuous tags like, for instance, images and so on, using attributes and stuff like that. Okay, so for some reasons, you want to allow the users to use HTML tags, and so you cannot just say, well, I'll forbid everything. That's a simple solution, but of course, it affects the usability of the website because the user cannot perform something that is supposed to be able to do. Okay, like using some formatting text and stuff like that. Okay, so I mean, the point. I mean, we are seeing examples of things that shouldn't happen in practice, because if you are using the techniques that we are going to see in a few minutes, okay, you try to avoid this situation without blocking completely the user from doing innocuous operations. Okay, so in this case, for instance, we should be very, very careful not to store text or in general code that has the potential to perform malicious actions. Okay, like a very simple example, forbid all script text. Okay, so before storing the information, somebody has to check if this this dangerous set of text like scripts and so on, and dangerous attributes are present. And in that case, decide what to do: reject the insertion, or maybe just delete the part that it is deemed dangerous, and so on. Okay. There are also say more sophisticated forms of cross-site scripting attacks. So for instance, we see this one, DOM-based cross-site scripting attack. Again, that's a link, okay? But I mean, it will be it's less evident than the previous one, okay? The user opens the link and so it sends a request to the website, but actually this time the important part is not that the request is sent to the website, it's that the link is processed locally by JavaScript, and this JavaScript code triggers some unwanted behavior, because there's a variable part in this URL that is processed unsafely by JavaScript. Okay, and typically it creates and interacts with the DOM. That's why it's called DOM-based cross-site scripting attack. And it creates something in the page that is not expected to be there, or it tricks the user in inserting some information that the user feels it's safe to insert because the page didn't change. Okay, I mean the page didn't reload, and so in the end, basically, this attack is about stealing against sensitive information, like password, like cookies, and whatever. Okay. Of course, again, this attack works as all the others because we programmed the page in a way which is not safe. Okay. So just to show you the example, okay? So somebody gives you a URL like this, myapp.com/list and hash, and the part after the hash, actually we didn't say it when we discussed HTML, but it's a way to have an internal reference in the page. So basically, the browser discards that part because there is no internal reference to move at a certain point in the document. But for some reasons, you use this information in your JavaScript code because maybe you wanted to store some information in this part that has a special meaning for your pages, and you decided to use the hash part to say at which point you are in your page. And depending on which point you are, you create some part of the, of the interface, and this is not safe because the URLs don't come only from your application, where of course you don't do things like this, but you only have a safe set of URLs, but yours can be created and accessed by any source. Okay, like as I told you, clicking on a link that has been sent to you by any means. I mean, it can be email, but also instant messaging, whatever. The important thing is that you open the browser with that URL, and so you load the code. The code goes to the URL. It takes a part and use it in an unsafe way in the page. Okay. So of course, I mean, it looks very, how to say, when you see the example, it looks very unsafe, right? I mean, you don't want to, I mean, I already told you it's dangerous to use inner HTML, it's dangerous to use eval, which is a JavaScript function to evaluate pieces of code. So basically to execute pieces of code starting from strings and stuff like that. But I mean, the point is that sometimes it's not just your fault. These things might happen also in libraries that you are using. and you're not aware of the fact that the libraries are using these systems, these methods and so on. Okay, maybe they do it only for simplicity, assuming that what is passed to the library is always safe and so on. Okay, so I mean, this is just to tell you that it's really important to check the code and avoid the usage of you know, the functionalities that are that often leads to problems. Okay. So in short, for this type of attack to work, there are dangerous, they call them sinks. Okay, so functionalities that you should avoid to use. Okay, if you click on any of the link in the presentation, you know, you have a way to go into more details about the cross-site scripting attack that we are seeing today. Okay, so for instance, well, I already told you this eval. Okay, but also document write. Actually, we didn't see it because, I mean, we don't want to create applications like this. But document write basically create something into the web page, and you can write HTML code. It's more or less like the inner HTML property, and then it gets interpreted by the browser. So basically, we are back to the point in which we can insert any kind of HTML code, and the browser then execute the code in case we have scripts or whatever. Okay, and as you see here, I mean, the list is quite long. I mean, something is not really so intuitive. Okay, like manipulating links in the page. Okay, so accessing the source property of any HTML tag in the page is dangerous, because, I mean, if you think when you program your application, you think, well, that's only my code. I'm sure what I'm doing. I will never put an unsafe link here. But if for some reason it happens that you take the information from an unsafe place, then it can go into that dangerous place, and so it creates a vulnerability. Okay. Okay. Looking at the attacks that we just mentioned from a different perspective, well, actually, I mean, classifying these attacks is not always easy, because I mean, we can think about them in terms of different properties. But one of the simplest way to classify the attacks are the attacks that are based on the server behavior. Okay, so it's something that is coming from the server, like we saw this injection through a link, or something that has already been stored. And so basically the browser simply execute something which is unsafe, but has been sent from a safe source, that is our web server. Okay, and then there are client attacks, where something is used to manipulate what the browser shows, or elements in the browser, so basically in the DOM. Okay, and the source can be of different types. I mean, it can be the DOM itself, it can be the server, or whatever. Okay, so in short, attacks can involve only the server sending something unsafe to the client, or the client processing information in some unsafe way. Okay, again, if you click on the links, you find more information. I mean, we don't really want to go into so many details on how to develop attacks, but rather than actually how to prevent these problems. Okay, so how can we, well, actually prevent, maybe it's an excessive word. We can mitigate the problems, because you're never sure you did everything it's necessary to actually really prevent everything. Okay, So we give now a set of rules which are to be followed to mitigate all, I mean, the possible, the known cross-site scripting attacks until now. Okay. Only use safe JavaScript methods and functions. Again, these guidelines, okay, tell you what to do and what should not be done. Okay, a set of rules and so on. Let me zoom it a little bit. Okay, HTML escaping, JavaScript escaping, carefully inserting untrusted data, and so on. Okay, a lot of things. Okay, I mean, we don't have time to cover all these rules, but I mean, we'll try to summarize the main points. So basically, when you handle untrusted data, so data that is not coming strictly from a source that you trust, okay, it must be treated only as text to be displayed, okay, never as code of any kind, okay. So this is what we saw in the beginning. I mean, we have this tag script. It's fine to show tag script. I mean, it's full of websites that show you HTML code. How do they perform this operation? Well, for instance, they convert sensitive characters. So let's say let's read them as dangerous characters, like the less than and greater than sign, into something which will not be interpreted as the start of an HTML tag by the browser. So there are special sequences that the browser interprets as, the browser shows in the same way, so as a less than sign, as a greater than sign, so it's fine for showing, but they are not interpreted as text, okay? And there are other dangerous characters to pay attention to, like the and, the single double quote, the slash, and stuff like this. Okay. This is called escaping. So transforming dangerous character in something that displays the same, but actually is a different sequence of bytes. So it is not interpreted by the browser as something that has an effect. Okay. Use only DOM methods to create dynamic DOM elements. Don't use the inner HTML and strings to create new HTML elements. I know it's really convenient because writing HTML is very fast, right? You just write the HTML code as a string and then let the browser interpret it and construct the DOM. But it's unsafe from the point of view of security, okay? So no inner HTML, no document write, avoid methods that run a val, that basically it's a way to pass a string and execute the string as it is, as if it were JavaScript content and so on, okay? I mean, it's a kind of rules that make sense in general, okay? But sometimes, we need to be extra careful to avoid, having something interpreted as HTML code. Okay. So there are libraries that implement this escaping function. Okay, because of course, if you do it yourself, you always fear that you are missing something. Maybe you didn't keep updated with the latest attacks. Something has been discovered recently for which, something is now unsafe. And typically, the developers of good libraries in this field try to keep updated with the latest attacks, and so they insert code to prevent those attacks. And for instance, for escaping, they consider all the set of possible sequence of characters or single characters, as we saw, that can be dangerous. Okay, and so if you are escaping through these good libraries, you expect that you will not have problems in this regard. Okay. For instance, just for an example, this is just an example. Actually, we are not going to require all this stuff for the exam. I just wanted to show you, all the problems that can happen in developing a web application, because probably you will encounter them later during your course of study, in other courses and so on. And so it was nice to play with JavaScript, HTML, and so on in the lab, but you need to be really extra careful sometimes. And if you are dealing with the content on the server side, so you have the possibility to run JavaScript code, as we saw with the node on the server side, that this validator package that has a method escape that allows you to transform basically every tag, every HTML tag, into something which is not dangerous from the point of view of putting it into a web page. So into something that appears the same, but is not executed by the browser, regardless of the content. So in short, it converts most of the dangerous characters in something that is not dangerous anymore. By the way, it's also available on Express Validator, on the return value of the check that you already saw in the lab. Okay, so if you need a validator by itself, you need to have a separate package. If you are validating inside the Express with the Express Validator, there is also an a convenience escape function on the check method. Okay. Okay. So it seems we solved the problem. Actually, not really, because sometimes you cannot escape content. Okay. Let's think of this scenario. You are developing a visual HTML editor. Okay. So people is typing HTML content. You press a button and you see the result on the side or on some other places around. Okay. That's actually what most of websites dealing with HTML do, right? So you go to the MDN, you see the code, you type the code, you press run, and you see the result, right? Actually, that's exactly this scenario. So, I mean, in this case, we are expected to execute the HTML code. If we want to see the result of the HTML code, we need to execute the code, right? So, I mean, there's no alternative. Okay, otherwise we should develop another browser, right? But we use, of course, the same browser. And in this case, we cannot simply say, well, let's just show something that appears the same, because appearing is not enough. We need to execute the content. And so this time, the problem is different. We need to sanitize the input. So having something that carefully checks what's the input and removes everything that is dangerous, but allows the rest to be executed. Okay, so HTML tags are left there unless they are really dangerous, like script, where I mean, basically you cannot simply allow any script to be executed. But things like we saw before, like the bold, or you want to insert an image or whatever, they should be allowed. Okay, but there are dangers also in these tags. And so basically, I mean, again, we need to rely on some packages or libraries that do the work for us, because otherwise we would need to keep up with all the problems, vulnerabilities, and so on that are discovered over time, in addition to the ones that are already known. Okay, and so our suggestion is search for a good library. Of course, we will try in this course always give you some advice, like this Don't Purify library. Okay, it's quite good in doing this work. and it removes potentially dangerous content when for processing by the browser. Okay, but the rest is left there as it is. Okay, without escaping. Just to show you a way in which you can use it in your code, in case you want to use it. So basically, you have this object on which you have this method sanitize. Okay, and if the method doesn't detect anything dangerous, it just returns the same string. Okay, if something is dangerous, like as we will see in the examples here, on error, and you can put JavaScript code in this attribute, for instance. Well, it just removes dangerous attributes, or even tags if they are really dangerous, like scripts and so on. Okay? But you see that the rest is the same. Okay? So it can be given to a browser and executed by the browser. So interpreted in this case, because that's HTML code. Typically, code is removed. Okay, JavaScript code is simply removed. Okay, so we saw two techniques. This is a recap. What's the difference between escaping and sanitizing? Escaping is leave the content unaltered. It appears the same, but it's not interpreted. So we found a way to have the same appearance, but make the browser avoid interpreting the code. Okay? Sanitization, instead, it changes the content if necessary, because it wants to remove all dangers from the content. Okay? So in the end, potentially we have something different. But in this case, we can safely interpret or execute this code. Okay? So that's the difference. Okay? It's important to keep this difference in mind, because depending on your application, you might want to use an escaping approach or a sanitizing approach. Okay? If you need to execute the code, you have no alternative. You just sanitize the content. If you want to have the same content, probably escaping is the way in which you want to proceed. Okay? And this is done to prevent all the previous problems that we saw. So this cross-site scripting attacks, either with JavaScript or HTML or both. Okay? Of course, if we use these techniques in the previous examples, in those three scenarios, they will not happen. I mean, we will take this input from the attacker, but at a certain point it will be escaped or sanitized, and so it has no effect, practical effect for the attacker. So the code is not executed and so on. Okay? Good. So also on the server side, well, server is probably the place where you need to pay most of your attention. Okay? Because if something is stored by the attacker on the server, then it will affect potentially all the users of your application. Because if they go and look for the place where the attacker has inserted the content, it's a problem, right? Because everybody will be affected. And so when you are on the server, you should always check what you are doing, either escaping or sanitizing what you are returning from the server to the client. Unless you are really, really sure that you already did the operation when you stored the information. So at a certain point in the server, content needs to be either escaped or sanitized. Okay? Actually, you know, since it's easy to forget doing these things, so sanitization, escaping, and so on, actually most of the frameworks that allows you to simplify the development of web applications, mitigate the problem as well. Okay, if they detect that some content needs to be inserted into the page and it comes from not from static content but from variables or stuff that has been loaded by the server and so on, they apply a very safe strategy. So no code execution is permitted, and no interpretation as HTML is permitted. Okay, and actually React is one of them. Of course, it's a good framework, so somebody thought of implementing these mitigation strategies as well in React. Okay, and these are just examples. I mean, just to let you understand that it's a very complex task, and so that's why we will avoid from next week writing our own code in JavaScript to develop our web application, because we risk so many problems that it's not probably worth doing it manually. Okay, unless there's a really good reason to do that. That means efficiency and stuff like that. But I mean, in general, if you rely on frameworks, most of the problems has already been addressed in some ways. And especially if you follow the guidelines on how to develop with those frameworks. So just a few examples. Of course, in HTML content, to avoid problems on the server, you should always either escape or purify the content. And it's suggested to do it before storing it in the database, so you don't forget to do it when you show the information back to the client. Okay, so in short, escaping is what is on the left side and sanitizing is what on the right side. In one case the content remains the same, it will appear the same. In the other, it will remove, I mean the dangerous content will be removed. Okay, for HTML attributes, some attributes are really dangerous and basically needs to be avoided. So if you sanitize them, they will be removed. Okay, and in general, I mean, you should try, let's say, avoiding this situation. I mean, for some cases, there's no specific way of dealing with the situation other than just removing the element, the tag, and so on. Okay. In the CSS context, in general, everything you do except setting values of properties can be dangerous. I mean, I don't want to go into details, but if you click on these links, you will find some details if you are just curious of what can be done. Okay, honestly, I don't remember what can be done in CSS, but you know, CSS is quite complex. Of course, I mean, the basic version is just you know, a rule, and that means property value, and that is not dangerous. But I mean, you can construct more complex stuff that can be unsafe. Okay, JavaScript, of course, I mean. If you need to show JavaScript code, it should always be quoted. So shown as a string, treated as a string, never as code. I mean, this is quite, you know, intuitive. And now this is not always enough. I mean, because if there is some code that takes a string, it makes eval, for instance, I mean, you're not even safe. You're not safe even with a string. Okay. If you're dealing with URLs, well, try to avoid you know, dangerous ways of writing the URLs. If you have special characters like the one that are typically subject to escaping, use the URL syntax to escape those values. You can represent any character here on the URL with the format percentage with the 2 digits, which is the X value of the character itself, and that is not interpreted later because there are actually 3 characters for the code, for the cross-site scripting code. Okay, instead of single one like the minus sign and so on. Okay, and so this is a link to a cheat sheet that is let's say a list of things to check if you want to be reasonably safe in this regard. Okay. Okay. Input validations for APIs. Well, actually, we already saw this point, right? Reject anything suspicious as soon as possible. That's why we insisted on input validation. Because, of course, requests can come from any source. I remind you, anybody connected to the internet, even from the other side of the world, can send information to our server. It's our task, as the writers of the code of the handling the API, to avoid problems for any kind of input. If we are not sure, just reject the request without processing it, okay? We saw some examples, right? The name of a person should not contain HTML tags, right? So, my name is not less than, script, greater than, Enrico, and so on, okay? So, also beware of quotation marks, spaces, and other Unicode characters, okay? Just make sure there are no kind of strange Unicode characters. Unicode characters are a set of 100,000 characters, including transparent characters, emoticons, whatever, okay? Let's put aside the emoticons. It's not that one is not a problem, but transparent characters or spaces or stuff like that can cause problems, because if you take this string, you use it to compose other strings and so on, and you don't expect there is a space or something which cannot be read or seen by the user, it can become a problem. Okay. When you need to deal with content that is potentially dangerous, like a snippet of HTML code, like in a forum where you discuss HTML and stuff like that, either use escaping before storing the content or escape it before returning to the client. The first solution is preferred because you do it once in a single place and you don't forget. Otherwise, you need to escape things every time you send back to the user, and there can be multiple APIs, multiple places where you do it. And if you only forget in one place, the attacker will find that place. Okay. So, and as you saw, it's quite simple. .escape actually modifies the content of the text, and then body text become safe. Okay. Okay, fine. And so, in short, for what we are developing by ourselves, that is basically the server, where we are not using frameworks except Express, basically. So just make sure you do a reasonable input validation, and when validation cannot be done, the content is at least escaped. Okay? So I recommend paying attention to these points. Okay? Good. So, final part of this presentation. These risks of cross-site scripting attacks has been increasing quite a lot in recent years. And so basically, browsers already provides ways of saying what is allowed, what is not, regardless of what they receive. Okay? And this is called Content Security Policy, CSP. So, in general, we saw loading code, JavaScript, CSS, images, as we saw in an example, from places different from our web server, from our original website. So the place where you loaded the first page of your website is really a big security risk. And so in modern browsers, recent versions of modern browsers, that means I think at least last 10 years or something like this, so not really so modern, you can say what is safe to load and execute, or better, you can say what is actually allowed to be loaded and executed. So you make a list of permissions, and everything which is not in the list is not permitted, okay, by default. This can be done in different ways. One of the ways is a specific HTTP header whose name is Content Security Policy, and it has a certain format. I mean, we don't want to go into too many details. I will give you an example just to, show you how these things can be prevented quite easily if the list is kept updated and in line with what you did in your website. Okay, and so for instance, says images can be this example. I mean, says these images can be loaded from any place. Script only from the website userscripts.example.com. Okay, so anything that is a script which is loaded from other places, including inline scripts in the HTML and so on, will not be executed by the browser. So the browser is another line of defense against these attacks in modern days, where you have a modern browser that is able to interpret these commands. Okay. So the content security policy is enforced by the browser since you first load the first page of your website, okay? And that defines basically what can be done and what cannot be done. The good thing, it does not require configuration of other web servers. So you can say that a certain domain is allowed, like the CDN domain, where we want to download, I don't know, the Bootstrap framework or the Day.js library and so on. But you don't have to touch the other domains. And indeed, you cannot, right? So actually, you just say in your website that those domains are safe for you. So it's fine for the browser to load content from those domains. And additionally, remember, you have the integrity check for that situation. And then you can mitigate cross-site scripting attacks because you can decide which scripts and which content can be actually interpreted and executed by the browser with a very fine granularity. So basically, before executing something, the browser asks itself, does it come from a source which is in the list of allowed source? Yes? Okay, I proceed. Otherwise, I stop. I will print an error in the console, as we will see later, and I will not execute the script or interpret the HTML and so on. Okay? So there is also a drawback. Of course, it's very powerful because it's sort of list of allowed things, but if you have a complex web server, it can become difficult to configure. Okay, because you have to take into account every single domain, subdomain where you can load scripts, HTML, content, and images and stuff. And every time you change something in the system configuration, you need to go and update the content security policy. Okay. This can be also implemented quite easily in Express. There's a package for this. I will give you this example already prepared and let's say with a reasonable configuration. Just remember to avoid the inline keyword here. Actually, it's a variable, right? That basically says, inline scripts are allowed. Those in which you put in the HTML the tag script, which is actually the most common way in which attackers insert JavaScript code in your page. Okay, because they cannot really change, the head part and so on, but typically they have effect on the body part because that's the part where the server changes the content or the JavaScript changes the DOM and so on. Okay. Also, note this is a very powerful strategy because even if you cannot really control the web server software, so the one that inserts HTTP headers. You can even insert this directive as a meta tag in the HTML document, and it will be read and interpreted by the browser. Okay, and this is very useful if you have files, typically static files, served by a CDN, where the web server is run by the CDN. The CDN decides which server serves HTTP requests, and so you cannot really say, well, add this HTTP header if it's not supported. And so you can simply put it into the HTML document, and that's enough for modern browsers, and it's quite useful. Okay, so actually I think the syntax should be more or less the same. It's just you can just use a different attribute, okay, a specific attribute for meta tag in head section. Okay, so as a summary of this bit long discussion is, in general rules to prevent security issues with your web application. Everything which is coming from outside the application must be treated as potentially dangerous. So must be escaped, sanitized, or simply not used if it comes from the list of unsafe sources, and not be given to unsafe sinks, as we saw in the slides. Always validate, escape, or sanitize the data before storing the data on the server. How do you choose between escape and sanitize? Depends on the application logic. If you need to preserve the content, you need to escape, but in this case, you cannot execute the content, and vice versa for the sanitize. When you return data from the when the data is returned or processed by the browser, the data must be either already be safe, because you already escaped it, you already sanitized it, or you need to perform the sanitization and escaping at that time. Okay, and there are libraries, we saw them, to do that. You can do it on the server side. You can do them on, you can execute them on the client side as well. Okay, JavaScript actually. We are using JavaScript for both server and client, so it's so easy for us. And whenever possible, use the content security policy mechanism to, have also a second line of defense against these attacks. Okay, I told you it can become complicated, but no, if it's not too complicated, try to use it, because it's really effective. Okay, it easily prevents a lot of problems like the inline scripting, which is the source of most cross-site scripting attacks. Okay. Okay. So today, basically, we are going to see a couple of other topics which are, much faster, much quicker, to explain, and then we will see an example which actually is already on the on the GitHub. We will add something a little bit more to to test, to see a cross-site scripting attack in action, and to see how it's easy to prevent it, especially with the content security policy, for instance. Okay, and then how can we escape and do all checks that are needed in case. Okay, but before going to the example, and I told you in case you want to explore it a little bit during the break, we have two other two other topics to see. Very quickly, because they are used in the example actually, and so in the meanwhile we proceed with the topics for the lecture. Where is the let me see. One is very, almost quite quick, I would say. Okay, So a particular API, that means a function available in the browser environment, which I didn't mention until now because we didn't need it for the lab. We just loaded things from a file. But once you program a behavior of a JavaScript application in the browser, at a certain point you might need to load the resources from a web server. How can you do it? With this fetch API, which is the actual modern way of doing it. Okay. So this is the situation. We have the browser. There is some JavaScript code that is handling the user interface, and that's what you wrote on Tuesday in the lab. Create node append child on the click of somebody did the optional part. You click the trash button, the delete button, and it takes a part of the DOM and it destroys it and so on. So basically it changes the user interface. And then we need something to interact with the server, right? So we don't have something to interact with the server at the moment in JavaScript. The only thing we can do to interact with the server is loading something in the URL, but actually it's not programming in JavaScript. It's the user accessing a new website, right? And then we have the API server, and that's fine. We already saw this part, right? So we are missing here something. How can we execute HTTP calls? So sending HTTP requests to the server from JavaScript code. Well, actually, there's a function available in the JavaScript environment that is named fetch. Okay. It's called API because it's, I mean, actually every function in programming can be thought as an API because it defines an interface by which you can access some functionality, right? But I mean, it's not a server API, it's just a function, JavaScript function. It takes as a parameter the URL of the resource, of course. You need to say where is the web server where I need to search for the resource. So HTTP or HTTPS, depending on the protocol, slash the host name, slash the path, and so on. Okay. So the normal URL that you would use on the browser URL bar. And then there is an optional object with some request parameters. Otherwise, the fetch will issue a get request. Okay, get as a HTTP method. You remember that we have 4 main HTTP methods: get, post, put, delete. If you say nothing, the fetch will do a get. It's available in almost any context because it's a method of the window object, and window is available everywhere in the JavaScript that you write in the browser. And surprise, it returns a promise. Okay, that's why we discussed a lot about the promises. But actually, it's also a very efficient way of dealing with this asynchronous operation, because requesting something to a server, it's an asynchronous operation. You need to wait for the answer from the server. And as we told many times already, you don't want to stop waiting for the server, because it can take a long time. You never know. Can be fast, can be slow. We don't know. Okay? And so, if we get the promise as a return, we have a way to attach some code, our callback, that will process the result of the fetch, so the returned value from the server, when it will arrive. We only need to understand how these objects are formed. I mean, how to process the promise and how to pass an object to the fetch to perform requests different from the get. Okay? The promise is always resolved as successful except in case of network errors. Okay? We will come back to this point. So, how we use it? We just write fetch. This is browser code. Okay, so it's loaded with script or inserted into a JS file that we load with scripts. Okay, and then it's a promise. So .then, .catch, whatever, or await. You can also use await. Just remember to do it in an async function, otherwise it gives you an error. Okay? And then you have a response and you use it. Okay? And we just need to understand how to use it. So, which is the object that is the object given by the fulfilled promise, and how to access the various information that is present. So actually the fulfilled promise returns a response object that has a number of properties. Again, you can click and look for the documentation and so on, but on the slides you will always find the most useful ones, the ones that allows you to start coding a little bit. So there's a property which is a boolean, but basically tells you which is the status code of the response. You remember that the web server answers with a status code, res.status, and you put a number, 200, everything is okay, 404, not found, 500, internal server error, and so on. So if the status is between 200 and 299, so it means it's in the OK range. OK is set to true. So it's a very easy way to check if everything went fine or not with the request. You also have the actual status number, the status text as well. Okay, the headers, because you know that in HTTP there are headers. So I think this is an object again with the key value, which are the headers of the response. The URL, well, actually you should know the URL, but in case of redirects, you have access to the URLs, the final URL. And the body, which is actually the body of the response, the one that contains the content, HTML content, JSON content, whatever content is sent back by the server. Okay? It's actually a stream, so we will come back to this point in a minute. So, would you like to test the fetch? Well, just put a URL. It can be anything on the internet. It can be, www.polito.it. It's fine. You can issue requests to any place. Okay? And response, and you can inspect the response. Okay, so this is just a callback that takes the response object, which is the value of the fulfilled promise, and just print something that is accessible as properties in the response object. Okay, just an example. How do we handle problems, errors? Well, as I told you, promise is only rejected for non-HTTP error. So internal server error, it's a fulfilled promise. Not found, it's a fulfilled promise. It's your code that must handle these situations. If the fetch cannot connect to a server, that's a rejected promise, because we have no response, basically, right? Any reason, we don't care. You have no network connection, you disconnected the cable after the request, which I don't know. Any reason for which there's a problem with the network, it's a rejected promise. Okay? But if the server answers something, it's a fulfilled promise, and it's your task to, it's your duty to decide what to do. Okay? So, suggested error handling approach. Well, actually, if it's a rejected promise, you don't have an answer from the server, so you will have nothing to do, basically. Okay, you can have a catch, but you probably, well, you might want to show something to the user, maybe say network error, try again later, something like this, but you cannot really do more than this. If you have an answer, well, first we suggest to check response.ok. If everything is fine, okay, you go and process the body. Otherwise, you need to check for the status code. But typically, again, if there is a problem with the status code, either you expect it and so you know what to do. like not found that you were searching for something, you can say, well, the list is empty or something like this. Or actually, if there is an error on the server side, again, you cannot really do that much, right? So internal server error, try again later, right? As many websites do. And so this is the typical code of handling errors, handling the response from the fetch on the client side. If not response, okay, throw error. It basically goes here. Here is just console log error, but it prints in the browser console. If you have a more useful user interface, you can have a place where you put some, I don't know, box or something with some text. And then if you can check the content type, for instance, since we said in our application we would like to use JSON for communication between client and server, we expect to find the content type header with the value application JSON. If it's not application JSON, it's a problem for us. We don't know what happened on the server, but we don't process the answer. Otherwise, we can process the answer. And you remember that we can concatenate the then, right? It's like a sequential awaits. If you use the then, remember to do return of the object that you want to have as a parameter in the next then. Okay? Without the return response, here response will be undefined and you have nothing to process in the next then. Okay? But this is standard behavior of the promises, right? Just a few options. For instance, I would like to send a post, a put and delete. Where do I put it? Well, actually, there's an object I can set with the method, with the headers, and with the body. Okay? Plus some other stuff that we will see only when it's needed. So, fetch with some URL, post, method, post, headers. Headers takes an object. Content type application JSON, body. Well, actually the post requires a body, and we put the object to send encoded in JSON format. That's our choice, but that's the choice for this course, okay? And also a very common choice, by the way. And this is a way in which you can perform a post on a certain URL using the fetch, okay? So everything which is in bold is actually really required. And this is a convenience method which is present in the browser JavaScript environment, actually also in Node, that takes any JavaScript object and serialize it as a JSON string. Okay? Everything is done automatically. Reading the we are almost done. Reading the response. Well, actually, I told you it's a stream and so on. Well, actually, we don't deal with the low-level method that access the stream because data can be big and can take a while to reach the client. And actually, we'll let the fetch handle everything by itself. And so that's the only method that we are actually going to use in our web applications. Response.json. So it takes an answer from the web server in the JSON format and reconstruct a JavaScript object that is actually the representation of what is being received through HTTP in the JSON format. Okay, so we receive a string containing bytes, and this will be converted into the corresponding JavaScript element. Can be also a number, a string, or more typically it's an array or an object. Okay, because typically you don't just answer with a single number or single value. Okay, typically with an array or an object because you have some information to communicate. Everything is done automatically for us. The only thing we need to remember is to insert the content type header in the server response. But we already did it, okay, in the code that we developed so far. Okay? So actually, how to handle the response? Well, let's see an example with await. Fetch, use a JSON. That's a URL. That's a relative URL. So from the same website where we started. Okay. Response, response.json. Actually, you need to know that JSON return a promise as well. So another promise. Okay. Because it can take a while to parse the JSON. That's why they made it asynchronous. Okay. But I mean, for us, it's not a problem. I mean, the only thing we need to know is it returns a promise, so it needs to be handled either with the await or with .then to do the next operation. Okay? Because we have a promise object, not the actual object, the JavaScript object. And then you do all the other operations as you would do, depending on the application. Okay? Yeah. Of course, you can issue multiple fetches in parallel. This is just a snippet of code. I mean, just there for reference for the exam, we don't really need that you issue fetch requests in parallel. But just because they are asynchronous requests, you can start as many as you like if they are independent, of course. If you need to wait for the answer of the previous fetch to do the second one, as before, of course, you cannot do the fetches in parallel, right? Otherwise, I mean, you can simply do a promise all. That is what we saw when we talked about promise. Run all the fetches in parallel and wait that all the fetches have loaded their content, and then process the content. I must tell you, I mean, it's not that common. I mean, there can be cases in which it's possible. As I told you, it's not required for the exam. Like I have a list of users and a list of courses and a list of whatever rooms at the university. There are 3 independent requests. I mean, I can run them in parallel. It's fine. I don't need to wait the answer from the of the user list to ask for which rooms are available at the university. Okay. I mean, there are things that can be run in parallel. But if I need to get a list of films and then I want the detail of a specific film, I need the ID. Of course, I need to wait for the previous fetch to finish and know that the ID exists and decide that's the ID that is interesting for me and issue a second fetch. Okay? Last slide, and then we will break for a while. Actually, fetch is not the only way in which you can handle this asynchronous request. There are libraries that can simplify the development of client-side code to load information from web servers. This is a very common one, this Axios. Actually, I must tell you, I mean, most people at the exam just use the normal fetch. Normal fetch is more than enough. But sometimes, in case you want to set timeouts, you want to interrupt the loading and stuff like that, well, with the basic fetch, it's quite complex to handle. Indeed, I didn't show it. Okay. Libraries can help you in this case because they provide you a better interface for these particular cases. But I mean, the basic fetch is more than enough for us and for experimenting with our web APIs, web server that provides these APIs that returns data for us. Okay? Just in case you are curious, or maybe you already used it, or for some reasons and so on. It's not forbidden for the exam. As usual, everything that is used in the exam, you need to be able to explain it. Okay? I mean, not, of course, every single detail is about every single library, but if you use the functionality of a library, I mean, we would like at least to know why at the exam and what it does if we don't already know it, right? That's a minimum, right? Okay. Okay, fine. So I think we discussed quite a lot. And we can break now, maybe 10 minutes or 15 minutes, depending on how much you are tired. I will prepare the exam, the example in the meanwhile, okay, during the break. And of course, if you have doubts, questions, I'm here to answer you. Okay, let's break.